Alright, looking at section 1.5, the idea of infinite limits. Before we start this, let's review rational functions. Okay, and I'm going to use this idea of p of x over q of x. You probably saw this in pre-calc. I'm going to say where p of x and q of x are polynomials. Okay, so as we talk about rational functions, we need to look at more specifically the idea of vertical asymptotes and also horizontal asymptotes. Vertical asymptotes are going to be what make your denominator equal to 0. So I'm going to say where q of x equals 0. So for example, if I gave you the function f of x equals 1 over x minus 2, you know you're going to have vertical asymptotes at x equals 0 and x equals 2. Okay, next area is we'll look at horizontal asymptotes. So for example, actually there's 3 different situations. If you have equal degrees in your numerator and denominator, okay, so for example, if I had the function f of x equals 2x squared plus 3x plus 5 all over 3x squared plus 1, as x got larger and larger and larger and larger, or smaller and smaller and smaller, really what's going to happen is the top and bottom are going to grow at the same pace because they both have x squared. So your horizontal asymptote is just going to be the leading coefficient, so 2/3. Okay. If you have the higher power or degree is in your denominator, so for example, if f of x equals 2x over x squared plus 1, as x gets larger and larger and larger and larger, you're basically going to have some number over a number in your denominator that's growing at a much faster rate. So if you think about this as a fraction like 1 over 100, 1 over 1,000, 1 over 1 million, you're going to be approaching 0. So your horizontal asymptote will be at y equals 0. Last situation. If the higher degree is in your numerator, okay, so for example, if f of x equals x squared plus 2 over x plus 1, your dominant power is your numerator, so your numerator is going to be growing at a much faster rate than your denominator. So in this case here, you're going to have no horizontal asymptote. Okay? All right, so let's look at more specifically how this is related to limits. Kind of review real quick here, is if you think about what we've learned about limits so far, we know that the first step, at least when we're evaluating algebraically, is we're just going to always try to plug and chug. Basically, can we just plug in the value and get a value out? Okay. The second scenario that we've been getting is this idea of 0 over 0, which is indeterminate. And we're going to have to use one of our 4 strategies. Factor and cancel, rationalize, simplify a complex fraction, or use one of your known trig limits. The next scenario that you're going to start seeing happen is that we get some number over 0. And this indicates that there's a vertical asymptote. Okay, so we're going to talk about that more specifically today. How do we deal with it? All right, so let's look at limits at infinity. I'm going to insert some more space here. Let's see. well, that's not what I'm going to do this right now. I'll see if I can fit it in this area. Alright, so limits at infinity. If we have, for example, the function f of x equals 1 over x minus 2, we know that graph looks like we have a vertical asymptote at x equals 2. Okay. And if I were to ask you to find, for example, the limit as x approaches 2 from the left-hand side of my function f of x, what you're going to notice if you plug in 2, so I'm going to do it here on the side, I'm going to say, okay, let's kind of test this out. If I were to plug in 2, I end up getting some number over 0, so we know that there's a vertical asymptote. Okay? And what you're going to want to do with vertical asymptotes is choose a value that's close to 2 coming from the left-hand side. So you're looking at the graph here. So choose a value that's close to 2 coming from the left-hand side. So like 1 or 1.5 or 1.99. And try to figure out, okay, is this going to be positive or negative infinity? So I'm going to choose 1. If I plug in 1 to my function, I'm going to get a positive number of 1 on the top. And on the bottom, I'm going to get 1 minus 2 would be a negative number. So hopefully you can kind of make a guess of what's happening as we come from the left-hand side. We would be approaching negative infinity. And you can see that on that graph as well, that's true. We're approaching negative infinity. If I asked you to find the limit as x approached 2 from the right-hand side, and again from the graph you can see probably that's going to be positive infinity, but if you were to test out a number close to 2 coming from the right, so like maybe 3, you're going to see that you get a positive number over a positive number. Okay. Therefore, let's see, I'm going to circle these answers. The last thing is if I asked you to find the limit as x approached 2 of f of x, we are approaching different values from the left and right, so it's not going to exist. Alright, last example before you guys do some practice. Let's say in this case here f of x equals x squared plus 2x minus 8 all over x squared minus 4. Before we do anything, let's kind of clean this up a little bit. We know we can factor the top to x plus 4, x minus 2, all over x plus 2, x minus 2. Write a simpler function of x plus 4 over x plus 2. Just kind of some notes about the continuity. At x equals 2, we have a removable discontinuity, right? That's our whole. At x equals negative 2, we have a non-removable discontinuity because we actually have a vertical asymptote there. Okay, so let's look back to what we were talking about today. A little bit more. The limit as x approached, let's say negative 2 from the right-hand side of f of x. You can see if you plugged in negative 2 to your function, either the simplified one or the original one, you're going to get some number over 0. So if we think about approaching negative 2 from the right-hand side, so as we come from the right, maybe we want to plug in negative 1. Okay, so if we plug in negative 1, we are going to get a positive number over a positive number. Therefore, we are going to be approaching positive infinity. Now, if I asked you to find the limit as x approaches negative 2 from the left-hand side of my function f of x, so as you come from the left-hand side, maybe plug in negative 3, you would get, let's see, a positive number over a negative number, so we'd be approaching negative infinity. Alright, if you grab that worksheet that you have that's about one side limits, let's look at the first couple problems together and then kind of go from there. Number 1a, x approaches c from the right-hand side, so as we come from the right-hand side here, looks like it would just equal 1. As we approach c from the left-hand side, it looks like it would also equal 1. And our limit as x approaches c of f of x therefore equals 1. Alright, the limit as x approaches c from the right-hand side, looks like it's going to be 2. As we approach from the left-hand side, it is also 2. Therefore, the limit equals 2. Number 3, as we approach c from the right-hand side, it looks like it's going to equal 2. As we approach from the left-hand side, it looks like it's going to equal negative 2. Therefore, our limit would not exist because we have different values from the left and right-hand side. The next video will show you more information for the following problems, so go ahead and watch that if you need any more help.